the question, okay, where you are being said that there is a survey which is being conducted on public accountants, chartered public accountants in US, and it was found that the average salary for the past 10 years, the survey was conducted for the past 10 years, based on the salary which is prevailing for chartered public accountants in US, United States of America. And it was found that the average salary is $74,914. That's the average salary. And this is the situation in front of us. So we are going to test based on mean, because average, mean. Okay, this is hypothesis based on mean. Now a researcher would like to test whether over the years this average has increased or not. After that, whether this average, he has taken up last 10 years. Now he would like to know whether this average has increased currently in the, because this survey was done 10 years ago. Now he would like to know in this 10-year period, has the salary been increased or not? Now we know that the general answer to that would be yes. We expect an answer to be yes in the normal condition. And as such, he's taken a sample of 112 CPAs, okay, and produced a mean salary of 78,695. This is the actual sample mean which you got, which that person got. He took a sample of 112 and he calculated the average, the mean, which appears to be $78,695, which is pretty higher than the average which was recorded at the previous survey. Now, when we have formulated a hypothesis, the hypothesis can be, the null hypothesis can be that the average, the average salary is less than or equal to 74,940. That's a null hypothesis. And if I'm trying to reject the null hypothesis, I would be formulating a hypothesis as such: the average salary is greater than $74,914. Right? That's something which we are trying to prove. Now, if I have framed a hypothesis like this, I should test it, prove it, and state that yes, this is it. Okay, it has increased over the period, and the standard deviation based on the data, based on the previous figures, it's been said the standard deviation, the variation expected is $14,530. Now we are going to test this in the crude way. Okay, now you can see that the H naught is less than or equal to 74,940, and the alternative is which is more than, that is, it is right tail test, because here it is said it is more than $74,914. So that's why it is right tail test. Now we have set the direction, we are going to test it. Okay. Now, as you can see, this is a formula which we already discussed. This is a formula where we manually, if you're going with a computation, we will go with this. But when we are talking from the perspective of computer calculation or software calculation, it is pretty difficult. Pretty different, where we talk from the perspective of p-value. But since we are going with the test statistics, here the formula here, x bar is nothing but the mean of the sample, mu naught is our mean of the population, which is given in the question. So we know that the mean being taken from the population, it's already given in the question, that was $78,695. We took that as our sample mean, and then the hypothetical mean which we got is 74,940. And the standard deviation, which is already been given in the question, which is denoted by this symbol, and it is 14,530. That's already given in the question. It's already given in the question. And then, as per the formula, it is root of n. So here, root of n is nothing but root of 112, because the researcher had taken 112 samples for his study. And the value we get, that is the test statistic value we get, is 2.7539. Now we know that when we are going with the right tail test, the critical value at 5% is generally we go with 5% significant level, stating that the chance of rejecting a hypothesis when it is correct, that is type 1 error. Okay, the alpha is maximum of 5%. critical region. So the rejection type 1, commission of type 1 error. And the value when it is right details, which we already had discussed in our previous classes, is 1.645. Now we find that the value which we get is greater than the critical value, which is 1.645. In the value which we get by doing this calculation, the test statistic value we get. Now, one thing here is the assumption is this is a normal distribution. That's the assumption which we have done here. That's why is a test statistics, and we get the values 2.7539, which is higher than the H0, the critical value, the value which is 1.645. saying that we are rejecting the null hypothesis, or it is said that we are in a position to reject the null hypothesis, accepting that the average salary has gone above 74,914 during this period. There is an increase in salary. This is we have done because this value falls here. It is beyond 1.645. So we are going to reject the null hypothesis, stating because the value has fallen here, stating that it has gone beyond the null hypothesis. So that's a chance factor where we are going when we are going with the calculation using a formula. But if the data is huge, if the figures are huge, if we cannot have a hypothetical mean, then we go with the assumption, we go with the software-based computation either in Excel or in SPSS, which is simpler, but we need to feed in the data correctly. If it is mean, likewise, you can also go with, yesterday somebody was asking about type of hypothesis. This is basically based on whether there is, you have already stated the direction of the movement of your data. You said whether you want to test the average salary has increased or not. That's the situation in front of us. We took the mean value. We checked whether the mean during the present period is higher or lesser. So this is the base of our hypothesis. The null hypothesis in this case should be less than or equal to 74,940. But since we expect that the average salary should have increased from this amount, we laid the alternative hypothesis that the average salary can be greater than 74,940. And after doing the test based on the value, we get that we are going to reject the null hypothesis, accepting the alternative hypothesis, stating that the salary has increased over a period. So this is actually testing of hypothesis, which we are doing. So during our previous classes, we said the steps, the procedure involving hypothesis testing is first is average score. Here we computed the average score to be the average salary during 10 years ago was $74,914, but during the recent sample we computed that this is actually hypothetical mean. Maybe sometimes we have the actual, sometimes hypothetical mean. When we are going with the machine calculation, software calculation, the system itself go with the hypothetical mean, and then we have the average being computed from the sample, which is representative of the population, and the value we get is 78,619. That's what we say as the first step. Setting up the hypothesis where we go with the average mean. If it is based on mean, okay, you can go with proportion. You can also go with the variance. It depends on the particular hypothesis or particular problem we have in our hand. And then we selected the significance level. In this example, we selected the significance level to be 5%. That's generally in social science research, we go with a significant level of 5%. 1% is maybe typically that's not a possible situation. And 10%, the acceptability of our result will be very less. So we generally take the median. In between, we go with 5%, which is acceptable everywhere around the globe. And we go with the test statistics. We did this using this formula. Before that, we had the hypothesis. We set the hypothesis stating that the average value the average salary for the sample is greater than what was average for the past, the last research which was conducted 10 years before. That is an alternative hypothesis. We say that the salary has increased. We are expecting that. That's a general logical sequencing of data. Logically, we expect that because of increase in the standard of living, because of increase in the cost of living index, naturally the salary also can be increasing. But we laid the hypothesis that it is less than or equal to. So that's what we go with testing. Now we got the critical value here 1.645, and the actual test value which we got using the type of distribution. Here we assume that it's normal distribution, and we go with the value decision. The decision here is we are rejecting the null hypothesis and accepting the alternative hypothesis, because the value, the test statistics which we get is 2.7539, which is higher than the value, critical value 1.645 at 5% significance level. So this is actually the procedure when we do in a practical situation. So I hope you got some idea about in real situation how are we going to perform the test.